See here what they have given is, first I'll transfer the videos to class. After that I'll start. See, more 1 hour class is there. Silently please attend. Now look here. Set A is having how many elements? 1 to 9. Correct? Now and R is a relation on A cross A. Okay. So R is a relation on A cross A. After that, what they are telling that this is related to this. Means what is the situation? See, before that itself, we have done these type of questions in long question answers questions, 5-mark question. This type question coming means close your eyes and say it is an equivalent relation. It is what type of relation? Equivalent relation. Got it? So this condition is a case of equivalent relation. Now what they are telling that the number of element in equivalent class is related to 2, 5. This is a typical question. How many 2, 5 equivalent class number of elements are possible? Come on, go for it. 2, 5 will be equal to the equivalent classes. Come on, go for it and start solving the question. Try this one out. How many are possible? 2, 5. Again, go for it. Understand how many elements are possible with that. See, I'm doing it again. A is having how many elements? Look here. A set is having how many elements? 1, 2, 3 till 9 is there. Then R is a relation on A cross A. R is related to A cross A and it is written like this. Then R is related to A cross A and it is written like this. After that, what is, if this is there, so what is the condition? A plus D is equal to B plus C. This is the condition. Okay. A plus D is equal to B plus C. Then they are telling, then number of elements in equivalence class is related to 2, 5. So here equivalent class means your equivalent class is given. That is this. Are you understanding? Here relation is having this and this. Understood? So that means A comma B you leave, another element will become 2, 5. Are you understanding? Instead of C, what is there? 2. Instead of D, what will be there? 5. Correct? So now this will be there. This situation will be there. And the situation is A plus D. D is what, beta? A plus 5 is equal to A plus 5 is equal to B plus 2. Correct? So here it will become A is equal to B minus 3. Are you understanding? A must be equal to B minus 3. Now how many such ordered pair will be there which will make it equivalent? Now say, already this situation is the equivalence relation. Understood? Now equivalence class we have to find. So what should be A value so that, what should be A value so that B minus 3, left side equal to right side. Think of an ordered pair where left side will be equal to right side. See, if A will be equal to 4, what will be A? 4. And B is equal to 5. Possible? 4, 5 is possible or not? A is equal to 4. B is coming as 5. So here 4. 5 minus 3 will be 2. Not possible. Correct now? So B should be what? You keep B value. You will keep getting A value. What is your situation? Your situation is coming as A is equal to B minus 3. Correct? So you start taking B. If I am putting B is equal to 4, what is the value of A coming? 1. A is coming as 1. So one element is coming 1, 4. Done. Next, you put B is equal to 5. If B is equal to 5, you are putting. What is A coming? If B is equal to 6, you are putting 3, 6. Correct? If B is equal to 7, you are putting. What is A coming? If B is equal to 7, you are putting. A is coming as 4. If B is equal to 8, you are putting. A is coming as 5. If B is equal to 9, you are putting. A is coming as 6. Now count 1, 2, 3, 4, 5, 6. Is 6 there in the option? Where is 6? Did you understood it? So Darunesh, A is equal to 6. Absolutely. So one more time I am teaching you. What is the relation given? Your relation given is, please understand, they already gave this relation as equivalence relation. Which relation they have given as equivalence, beta? They have already given this relation as equivalence. A plus D is equal to B plus C. This part is coming as equivalence relation. Understood? So equivalence relation, that means what? A comma B is related to C comma D. It will become what, beta? Equivalence relation. It is coming as what? Equivalence relation. Done? Now, they're telling that this becomes equivalence class. What it will become? Equivalence class. So when it is equivalence class, what we have to do? Equivalence class 2, 5 given. That means relation, first element will be as it is, second element is getting fixed as 2, 5. So now A will be as it is, D will become what? 5. D will become what? 5. B will be as it is. C will become 2. So that means A is equal to B minus 3. Now one by one, A and B both belongs to what? A only. So A and B both belongs to A. And A is having how many elements? 1, 2, 3, 4 till 9. Understood? A is having how many elements? 1, 2, 3, 4 till 9. So here, since A is having these many elements, now one by one you have to start substituting B value. You started substituting from which value? 4. Greater than 3. Understood or not? You substituted B is equal to 4. A is coming as 1. Then you substituted B as 5. You substituted B as 5. A is coming as 2. Then you substituted B as 6. A is coming as 3. Till you substituted B as 9. A is coming as 6. Correct, na? So that means how many set came? 6. That's a very important question. Please kindly don't leave these type of questions. Did you understood equivalence relation, equivalence class? So this is again another important point. Please refer the video. Now we are going towards function. Understood or not? So before starting function, I'm giving you the concept of function one more time. Are you ready for functions? Okay. So first I will teach you the concepts of function and then I'm teaching starting function. Got it? So one more time I'm teaching you the concepts of function. So one more time I'm teaching you the concept of function. Get ready? So when we are starting the concept of function, let's see how function part is coming. So here in function section, one by one, I'll explain you all the details of function first. From the beginning, 0 level functions we are going to understand. See, relations and functions, first understand what is the difference between relation and function. All functions are relations. Note down one small things you write. All functions are relations, but all relations are not functions. Okay, Now, what in all are the terms and conditions of function? One last time we are going to understand how we are proving onto function and how we are proving one function. Both we have to study. We see first they were talking about in different type of functions. Now they are not listening that. They are just saying not onto, not into. Correct? Now they are not talking about into. If you precisely check, they are not talking about into. They're not talking about what? They're not talking about into. Now, beta, one by one, I'll explain. One by one, I'll explain everything in functions. First part in function, if you have forgotten function, like what is the basic conditions and terms and part of function, one more time understand. Function will have, this part will be called as domain and this part will be called as codomain. Understood? Mapped elements are called as range. Whenever we are writing f such that a tends to b, a will become your domain and B will become your codomain. Mapping is done from A to B and it is written as F. Got it? So now this A will be representing x-axis value. B will be representing y-axis value. Mostly like this it is there. Please kindly note down. So whenever you are writing function beginning, I am starting Shivaranjani, whatever doubts are there for board examination, keep asking the doubts. I will clear the doubts now itself. Last moment we will have time only for revision. Understood or not? So what we learned here right now, we learned a very important topic here. The most important part is कि first this will become x-axis and this is coming as y-axis. Understood or not? So now x-axis and y-axis part we have done. Now next important section is कि this part is called as domain and this part is called as codomain. Got it? A will be called as domain, x values. B will be called as codomain, y values. Understood? So now beta, whenever function you are writing, you are always writing y is equal to f of x. You are always writing y is equal to f of x. Today chemistry class was there at 7 o'clock, na? Sir told. I hope you might have understood this one. So this is called as domain and this part will be considered as codomain. The mapped elements are called as range. Till here you understood? Huh? Next part is domain, codomain sections done. Correct? So now next section is how we are proceeding. Just 1 minute. Hello sir, today class is there sir? Okay sir. Okay. And sir, that I will message you. You please kindly send me that detail. Okay. Please understand this part. Next section, when we are going for it, sleep. Okay, I informed in this group. Now please pay attention, beta. Can I start? Now look, beta. When we have done till here, chemistry class, how many of you are going? Nobody is going. Right. So now look here. So now we are going to go for this next part. If you will torture me, means I will not teach. Now I'm going to teach you different type of functions. Okay, then how many functions possible, everything I'm going to teach you. But first understand, function says that it has 2 to 3 rules, most important rule. The first part of the function is, one more time I'm explaining, please kindly do it. If the domain is ABC and codomain is this, can you check one thing? This input is having 2 outputs. Is it possible? Answer is no. One input cannot have 2 outputs. It is not a function. Huh. One input cannot have, one domain element cannot map with 2 codomain elements. This is important. Understood? This is not possible. One input cannot have 2 outputs. Please note down this. I hope you might have understood. One input cannot have 2 outputs. But now next part is, 2 inputs can have like A, B, C, D, E, F, G, H. So A to E correspondence, when 1-1 correspondence will be there, it is called as 1-to-1 correspondence. 1-to-1 correspondence. Single. 1-to-1 correspondence is there. Now, when this part will be there, a, B, C, D, E, F. This will be considered as many one. Many inputs are having one output. 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 That is called as what, beta? Many one correspondence. I hope you might have understood. Many one. What it is considered as? Many one. Many input is having one output. Understood? This is called as 1-to-1. This is many one. Now 1-to-1 will come with into and onto. But nowadays we are not using the word into. We are not using the word into. Understood not? We are saying it is not 1-1. It is not. We are not using the word many one. We are only saying it is not 1-1, or we are only saying it is not onto. Did you saw the change in the statement? We are not using the word many one, and we are not using the word into. But onto word we are using, and 1-1 word we are using. Understood? So now when it is 1-1 onto, what is the meaning of it? 1-1 is called as injective. Note down. Onto is called as surjective. Together they are called as bijective. And its inverse is possible. This is the most important information in precise I have given. Injective and surjective together will become bijective. Injective and surjective, which way you want to go means you can go. Injective and surjective together will become bijective. Hmm. Done? This is called as inverse is possible. This is most important part. 1 1 onto. 1 1 is called as injective. Onto is called as surjective. Together is called as bijective. And its inverse is possible. How it is? Look here. Example we will do. In this bijective function, if it is A, B, C, and this is D, E, F, you see. So here, all codomain elements are equal to range. Understood? So single correspondence means it is 1, 1. And here, all codomain elements are mapped. Here, all codomain elements are mapped. So since all codomain elements are mapped, it is equal to range. Understood or not? So when range is equal to codomain, it is a case of onto. When range is equal to codomain, it is a case of onto. Did you understood it? Range is equal to what, beta? Codomain. And that part it will become case of onto. Did you got this point? So this is the first part. Range is equal to codomain. See, this time I am telling you I will not teach because within 24 hours, this girl again, punch this girl, full time doing unwanted works. Now understood or not? So here, this is exactly most important. So did you understood this part? 1 1 onto function, did you understood? 1 1 onto is bijective. 1 1 is called as injective. Onto is called as surjective. Together it is called as bijective. And its inverse is possible. Got it? But here, many one is nowadays called as not 1 1. What is the another word we are using for many one? Not 1 1. When we are using the another word for many one, not 1 1. We are calling it as not 1 1. Many one says that like A, B, C is there, D and E is there. Two inputs are having one output. Two inputs are having what? One output. So this is exactly called as what? This is many one. You see here, one very important thing. Codomain elements are what? Codomain elements are D and E. What is your range? Only D. So range is a subset of codomain. Then it will not be into. So it is not into, not onto, sorry. It is not onto. And when it is not onto, it is called as into. I hope you might have understood. Good evening, Soris. This is the third video. Please kindly refer these videos. It will be definitely very helpful for you for finishing chapter 1, relation and function. So 4 to 5 mark will be in your control. If you are going to watch the video, all the details I have given in that. Now I am going to give you massive details. Understood? This is just the first part, beginning section. So whose function inverse is possible, beta? Everything is there in the video, sorry. 2 videos in the group it is there, and that 1-2 videos are playlists, and it is already there in your group. You just watch it patiently, you will get all the answer. I hope till here it is clear what it is called as 1 1 and what it is called as onto. Now function test. What is the meaning of vertical line test in function? Understood? This is the first basic preliminary thing I taught. Now second part is what is called as vertical line test. What is the meaning I said? Vertical line test. So if any function graph is like this, is it a function or not? You only have to draw vertical line. When you are drawing vertical line, you see one value of x is having two values of y. It is not a function. One input is having how many outputs? Two outputs. Is it a function? No, it is not at all a function. Remember this one. One input should not have two outputs. So it is not at all a function. I hope till here it is crystal clear that this part is not going to be a function because one input is having how many outputs? Two outputs. So whenever an input is going for two outputs, it is not at all going to be a function. Till now, how much we have studied? What is the meaning of injective, surjective, bijective? Only bijective inverse is possible. Bijective inverse is possible. Otherwise, its inverse is not possible. I hope you might have understood till here. Now we will go for the next part, function. What? Now understand one thing. Now listen. Now if somebody will be asking you about function and relation. Now if a set will have how many elements? Write down. A set A M elements. Shivaranjani, you asked details about it. See, I am giving you the details. A set A is having how many elements? M elements. Set B having N elements. Then how many functions possible? So total number of functions possible. Total number of relations possible total number of function possible. So total number of relation possible is check 2 to the power mn beta. Understood? But total number of function is n to the power m. Understood? Where n is number of elements in set B. M is number of elements in set A. This is most important part. Come on, go for it. So this is Sivaranjani. Did you understood this one, beta? This video is very, very important for you people. This is the third video for today. You must watch this video. You'll get all the answers. How many functions possible, beta? If somebody will ask how many relations possible, relation is nothing but subsets. Don't forget to watch the first video. It will give you closer for relation chapter. I have done it very nice. Ask them. Okay. Second also, but I was distracted by you people. So now listen. Please remember this part. If somebody will be asking you how many functions possible, what is the answer? N to the power m. How many functions possible? N to the power m. Now somebody will ask total one function possible. Okay. One function possible. Total one function possible. Note down how many one functions possible. Sivaranjani, this you did not ask me, beta. One functions possible. There should be one very important condition. Remember, m means should always be less than n. M means what? Number of elements in A. Number of elements in domain. M is what? Number of elements in domain. And what is N? Number of elements in codomain element. Codomain. So 100% number of element in domain should be less. Are you understanding? Either equal or less. But domain element should not be more. But domain element should not be more. Okay. So in that situation, how we are going to solve? Then we are only going to write permutation condition NPM. Codomain element number, permutation, domain element number. So it will become n factorial by n minus m factorial. And this will give you total 1 function. Write down, this is most for competition to everywhere. It is the most important part. Shivaranjani, happy? This is the biggest part I am giving. Last moment itself I am giving. Understood na beta? That means what is the most basic condition? The most basic condition is domain number of elements should be less than codomain. Domain number of elements should be less than codomain. Understood na beta? Now here the next part, they are telling that onto function. How many onto functions? Number of onto functions possible. For that, reverse has to be there. What is the reverse section? M should be greater equals N. M should be greater equals N. Understood? Only for onto, not bijective. This is the case only for onto. Done, note down better, please. This, like this type, you will never study. What is the time now? 10 minutes is there. Now better look here. Total number of onto possible. For onto possible, m should be greater equals n. For this, we are writing formula n factorial s m comma n. Write down. N factorial s m comma n. Please kindly write down very nicely. I hope you might have understood. So SMN is called as Starling number. Write down STAR. This is called as STARLING. Starling numbers. What is actually the meaning of Starling numbers? Understood. So actually Starling numbers means a set will have 3 elements. Just check. A set is having 1, 2, 3 elements. So how their sets are possible? So it will be divided like this. A will be there 1, then remaining will become 2 comma 3. If it is 2, then remaining will become 1 comma 3. If it is 3, then remaining will become 1, 2 comma 1 comma 3. Understood? So this is called as Starling numbers. Got it? So Starling numbers will be those numbers which will be exactly separated from others. Generally onto they will not ask you. Onto functions they will not ask you. They will ask maximum 1. But I have given. Yes, if you will have 3 elements, then how many starting numbers will be possible? Understood or not? So here, if 3 elements will be there, then starting number possibles are 3 only. Correct now? How many starting numbers possible? 3. So if 3 elements are there in a set, then starting numbers is coming as 3. Like that only. So how many elements will be there? Starting elements will be dependent on that only. So now we are going to go, another formula is there, but we will not be doing it. Onto functions, number of onto functions, they will not ask. Okay. They will not ask. So now we are going to go for the next one. Ready? Huh? Fine. See, my target was to teach more today, but you people are not ready to understand this. See, like this is not the case of students. You do one thing. You bring your tea, lunch, dinner, dress. Understand? Not? You eat and you study, but you study, please, because you are distracting me like anything, or you don't come. That is the only thing I am telling you, because student means student only. I'm not like that. I'm a very disciplined person. I'm teaching nicely, is teaching. Lots of phone calls, messages are coming. I'm just messaging and telling I'm in class, live class. This much I'm doing, so that you will not get disturbed. In return, what you people are telling? I want tea, I want coffee, all this. Students are continuously asking, yeah, what time class, this thing, that thing. I'm just managing everything. Don't do like that. For you people, I'm closing everything and keeping class. And you are in return doing this. So did you understood about starting numbers? So now you came to know how many functions possible? 1 I think 1 is much easier now. How many 1 possible? If they will say means NPM. Mostly NPM starting numbers is little difficult to understand. One more formula I am having that I forgot, but that is onto function formula. I'll find it and I'll give it to you. Easy formula, okay? But this I'm remembering. N factorial, n function means n to the power m. 1 means NPM, where n is greater than or equal to m. But beta for bijective function, what is the case situation? Bijective function number of, when bijective function is possible? Bijective function is possible. Bijective function is possible for function f such that a tends to b when both a and b have same number of elements. Understood or not? So when bijective function is possible? Bijective function is possible. See, how bijective, can you check? A and B is there. So A and B should have 1. So how many elements present in A? 3. How many elements is present in B? 3. So when they have same number of elements, then only bijective function is possible. Otherwise, bijective function is not possible. I hope you might have understood this one. So this is a very important situation, condition. Please kindly understand this part. It will be very, very helpful for you. This is a case of bijection in function. Most typical sections I have covered. Okay, most typical sections I have covered: injection, bijection, and surjection. Understood? Surjection is onto, injective is 1 and bijective is 1 onto. Did you understood till here? So this is the only situation. Tomorrow can I start solving questions? Okay, you come fresh. First I will teach you which functions are onto 1. But what is the time you people are coming, that I need to know. Time give me accordingly, because TKM I have to give. Otherwise TKM student will be finding difficult.